Alright, this is going to be the third part of the Similarity and Congruence Review Day 2 video. So this is going to cover the last page, problem 7 and 8. So these are the two proofs. Alright, first proof, number 7, is given that C is the midpoint of BE, angle BE is congruent to angle E, and AB is congruent to DE. So some of this is already marked. Angle B is congruent to angle E. AB is congruent to DE. And then it tells me that C is the midpoint of BE. Okay. So the first thing I want to do is, well, what does that tell me? Right? I mean, before I even start looking at the proof and what I have to fill in, what does that tell me? Well, if C is the midpoint of BE, it cuts BE in half. That's what a midpoint means. And if it cuts it in half, cuts it into two equal pieces, so that BC and CE are congruent. All right, I can use that now to prove that triangle ABC is congruent to triangle DEC. So that's ABC, DEC. What am I going to use? Before I even start looking at it, just I don't know, figure it out. What am I going to use? I'm going to use side, angle, side, right? Side, angle, side. Angle is the included angle, so I can use that. It's not SSA or ASS, which we know we can't use. All right, so what do I have? Angle B is congruent to angle E. Well, that's given. So that's my reason there. AB is congruent to DE. That's also given. Okay, so that's fine. What's the other thing that I'm given? I'm given that C is the midpoint of BE. All right, and then here, what thing do I know because of what midpoint? I think this is supposed to be like the definition. Midpoint. Well, I know, like we said, we know that BC is congruent to CE. All right? And then we've got our three things, right? We've got our angle, we've got our two sides, and this angle is included. It's between the two sides, so we can use SAS to show that triangle ABC is congruent to triangle DEC. All right? So that's 7. 8 is pretty similar. What are we given? We're given that Q is the midpoint of PR, PS is congruent to QT, and QS is congruent to RT. So some of this is marked. QS, RT, those are congruent. QT, PS, those are congruent. We're given that Q, again, is the midpoint of PR. So what does that tell us? It tells us that Q splits this segment PR into two equal parts. So PQ and PR are going to be congruent. All right, let's go down. Oh, and then let's think, if we're going to try to show, what are we trying to prove? That PQS is congruent to RQT, PQS, triangle PQS, and triangle QRT are congruent. What theorem are we going to use? Of our 5 triangle congruence theorems, side, side, side is the one that makes the most sense because we know about all 3. We know about 3 sides of both triangles. So, first thing, what are we given? We could put anything here. Well, we know we're going to have QS and RT here, so that's given. So we're not going to use that. We could probably just we can cross that out of our list here. Well, we know that PS is congruent to QT. That's another given. And the other given, the last given, is that Q is the midpoint of PR. Okay, so we've got all of our givens there. What do we know because we know what a midpoint is? This, again, is like the definition of midpoint. Well, we know that PQ is congruent to QR. Right? PQ, QR. And then from that, we've got our side. We've got a side. We've got a side here, and we've got a side here. Side, side, side. So our triangle ABC is congruent to triangle DBC. This is the right letters. It should be triangle PQS is congruent to triangle RQT. Yeah, that's a little mistake. That's not my mistake, just for the record. And we know, and what's our theorem that we're going to use to show that those two triangles are congruent? S, S, S. All right, that's it.